you guys I don't know if you guys saw it, but I went through the exam online, all the answers with the other class, and I posted it. Did anybody see that by any chance? You saw it, Thanos? Okay. So those of you, I mean, it's still, I put in a tech support, like I put in a tech support call for, what's it called? I put in a tech support call for them, but right now it's kind of like out of my hands, all right? So, okay, can you guys see my eclipse really quickly? Okay. All right, so today what we're going to be doing is we're going to be going over searches, okay? So there's only two that you really need to know, okay? All right, the first one is a linear search. So let's start off with that. Int array x equals all right. Okay, so what I want you guys to do, all right, is I want you guys to just right now, this is kind of just like a warm up, okay, is I want right now, I want you guys to, hold on one second. I want you guys to search for the number 12. Do that right now. Hello. Okay, so what we're doing is what did I say what we were looking for?
Number 12.
Yeah, 12. Okay. So right now, this would be what we call a linear search. And basically what we're doing is we would use a for loop, and we would say for int j equals 0, j is less than x dot length, okay, j plus plus, all right? And then what I would do is very simple, okay? Now, if this wasn't a method, I would either return true or false, okay, to see if something was in there, okay? So in this case, what I would do is I would say if, and we'll say, we'll call this the key, okay, int key equals 12, okay? Now, what I would do in a standard search, what you guys would do is you guys would do comparison by comparison by comparison. Now, luckily, we're here that it's the first one, but let's move it to here, okay? So if key is equal, or if, sorry, x index j is equal to the key, true, okay? Else, all right. So this would be what we would call a linear search. Now, what is the number of times that we could, what are the max number of times that we could search for something here?
Length of the array.
Length of the array minus
1.
1. Okay, because the length of the array minus 1, because by that time you would have found it. Okay, by length minus 1. Okay, because if you start searching the length, think about it, you're gonna have an overflow error, Dylan. Okay, so, or not an index out of, you'll have an out of bounds error. Okay, so this is straightforward. How many of you feel comfortable with this linear search? Okay. If I were to ask you to search for a number or some type of a string value that you feel you could find it, raise your hand. Raise it high. Okay. So again, This is just a linear search, and all it is a comparison. It's pretty easy to do, okay? And the key thing, what have we noticed about a linear search?
It goes through it by one.
Are the numbers sorted?
No.
No, they're not. Okay, that's a key thing. With a linear search, the numbers or the array does not need to be sorted. Okay, now remember that if this is an object array, it's going to go by the parameters and it's going to sort them by the first parameter. If it's numerical, if it's a numerical parameter, it'll go by numbers. If it is a string parameter, it's going to go by the ASCII table. Okay. By the way, side note, Alex and Euban, you guys are excused for tomorrow. I wish you guys best of luck. Okay. All right. So now what we're going to do though, is we're going to move on. Okay. What we're going to do is we're going to move on to the binary search. Okay. So the binary search. All right. So we're going to look at it from two approaches. Okay. So we have binary searching, and then we have the binary searching and iterative approach. Okay. So what I want you guys to do is go ahead and fill this in right now. Go ahead and copy these two method signatures. Okay. Notice they're static. Okay. So go ahead and do that right now. Oops. Okay. All right. So first of all, let's talk about, so what I'm going to do really quickly, guys, is we're going to keep this array. And what I'm going to do is I'm going to make this just a block method. Okay. Now, okay. So we're talking about these arrays. Okay. So the first thing that we need to do, with a binary array, if we are going to work with a binary array, is we need to sort this array. Okay, what is the shortcut that I've taught you guys to do? Anyone? You guys know this. What's the shortcut to sort an array?
Arrays.sort.
Arrays.sort. Okay, do not be afraid, okay, to do that or to use arrays.sort. Okay. The only thing that you'll need to do, it's like hit or miss. If you are going to use the arrays.sort, if you by any chance, there is a good chance you could get like a binary search question. If you do have to do arrays.sort, just put a comment code. Okay. Just put a comment code saying like, just basically saying like, I've already imported the arrays class. Okay. Something like that. Right. Or assume that the arrays, all proper arrays imports are done. Okay. So I have arrays.sort x. Okay. So at this point now, my array is going to basically be 1, 4, or -5, -35, et cetera, et cetera. Okay. Do we all understand what the arrays.sort does? Okay. So let's take a look. Basically what happens with the arrays, with the binary search is this, is you then take these numbers. Okay. So actually, let's go ahead and do it. We have the time. Okay. I feel like I'm rushing for some reason. Okay, so now the array is sorted as -35, -5, 1, 4, 12, 34, 67, and 69. Okay, so what a binary search does is this. Okay, the first thing it does, okay, is it splits the array in half, okay? And it checks the midpoint to see if the midpoint is the actual key, okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, okay? So it checks the mid, okay? So in this instance, this would be the mid, okay? Then let's say, like, what's the best way to do an example? Okay, let's say we have a dictionary. Okay, let's say we have a dictionary, and the word that I'm looking for is xylophone. Okay, if I split the book in half, okay, and I get Mary, do I know that I have to look at this side of the book? No, I don't. Okay, so what I'm going to do is I'm basically cut it in half, like. Okay. All right. So I've got a book here. Okay. I've got this book. All right. Let's just assume that this is encyclopedia. Okay. So I've cut the book in half. All right. Here's my half of the book. All right. Now I'm looking for the word xylophone. Okay. Now on this side would be basically A through M, and here is N through Z. Okay. So do I even need to look through A through M now? No. So then what I do is, let's say I split this one in half. And I get to the T's, okay? So I'm at T's, okay? I know xylophone was after T. Do I even need to look at this half? No, okay? Then I split in half again, and I get to the X's, okay? Is basically now at this point, am I probably getting close to where I need to be? Yes, I am. Notice that I'm basically doing half, 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 okay? So with the sequential search, basically what I'm doing is, okay, with the sequential search, what I'm doing is I am basically saying n minus 1 possible times that I could search. Where with the sequential search, or with a binary search, I could do n divided by 2. Then it turns into n divided by 4, n divided by 8, et cetera, okay? For those of you that are math major or math people, you guys should know that it's a simple log equation, okay? It's a log to n equation, even though the base doesn't really matter, okay? But it's a natural log equation. So if you were to ask, if somebody was to ask you, well, how many times, you'd say log 2n, okay? You don't really know what the base is yet, but it's a log to n equation, okay? So for those of you algebra 2, you probably understand that. For those of you who don't know math, you're screwed. You might you might just have to take it for as is, okay? So that being said, let's move on to our binary search equation, okay? Our binary search method, all right? So the first thing that I want to do, okay? So notice that I have 4 parameters, okay? I have the array. I have the key. Now the key is basically the number that I'm going to be looking for, okay? Then I have int left and I have int right. Now left and right are basically the index values, So in a primary binary search, okay, the left is going to be 0, which means the right is going to be what?
Add -1.
Length minus 1. So yeah, so Ian, if length is n minus 1. So the first thing I want to do is I want to do an error checking, okay? So this is a Boolean method to see if in fact the search is there. So what I'm going to do is this. I'm going to say if left is greater than right. That's the first thing I want to do, okay? If left happens to be greater than right, I'm just going to say return false, okay? Great. If left is greater than right, then I'm going to return false, okay? Now, once that's basically, this is just an error checking to make sure that, you've got a valid array. All right. Now, the next thing we're going to do is we're going to find our mid. We're going to find our mid. Okay. Now we're going to say int mid equals left plus left plus right. Okay. Int mid is left plus right divided by 2. This is going to give us our middle index, okay? Now, the next thing we're going to do is we're going to do an initial test to see if the key is equal to this mid index. So now what I do is I say if array mid is equal to key. Okay, so if array mid is equal to key, then I'm going to return true. Okay, Are you with me so far? Okay. Now, as I've told you guys, this is kind of recursive. So if array mid equals key would be similar to our base case. Okay. Now, the next thing that we're going to do is this. Okay. We're going to now check to see our first value. Okay. So if it's the middle key, great, we've returned it. Otherwise, what we're going to do, okay, is we're going to check the left-hand side. So we're going to say else if key is less than array index mid. Okay. So if key is less than array index mid, okay, if that is the case, then what we're going to do is we're going to return binary searching, but we're going to have different parameters. Okay. We're still searching through the array. We are still using key. Okay. Left is still going to be 0, but this time our right is going to be what?
Mid.
Divided by 2.
Nope. Oh, come on, Dylan.
Divided by 2.
I have mid. So I have mid.
Minus
Oh,
1.
mid minus 1.
Mid minus, thank you. Okay, I have mid already. I've just checked mid on line 31. Okay, so now I'm checking the left-hand side. Okay, so I'm checking the left-hand side. And what happens? Because I've checked it now, that means basically I'm going from 0 to that mid minus 1. Okay, so that being said, if it's not otherwise, if it's not less than, it's got to be greater than, correct? So now if it's greater than, I'm going to return binary searching the array again, the key, but what are my parameters now?
Mid plus 1 to right.
Very good. Okay. So do you guys see how this is working? Okay. So as you can see what is happening, it's splitting each thing in half and checking the mid. Okay. Essentially, basically just testing each one until you get to the right number. All right. And as you can see, it's a very fast search. Okay. It's definitely faster than if you were trying to do this like a linear search. Okay. All right. So that is our binary search. Okay. Does anybody have any questions so far on the binary search? Are they confused? Go ahead, Gary.
So in order for this to work, the array has to be sorted before.
100%, it has to be sorted.
Okay.
So for example, and there is a chance like this to test recursion and sorting, this would be the only thing that I could see them maybe bringing in recursion. Is there a possibility you would have to write recursion on the free response? Yeah, but binary search would be the only reason why I could see it, okay? But sorting, you would have to always sort the array.
All right.
Okay. Anybody else? Now's the time. Okay. Do we understand how this is working? Okay. What is this very similar to?
Merge sort.
Who said that?
Eon.
Eon, wait, good job. Absolutely. This is very similar to a merge sort in terms of a divide and conquer approach. Okay. So Lance, are you good? Lance, you look a little puzzled. And I'm not saying like to call you out. Like this again, team effort. Do you understand what is happening?
Yes.
Logan.
Yeah.
Okay, good. So now let's talk about iterative. Okay, the iterative way. Now, when I say iterative way, basically what I'm talking about, move over. Okay, so basically what I'm talking about when I say the iterative is how can I do this without recursion? Okay, basically the old school way. Okay, just straight up. Okay. So what I'm going to do right now is, if you guys make this iterative method, thumbs up. Okay, good. So what I'm going to do right here is I'm just going to copy and paste all of this real quick, because all we got to do is got to just do some minor tweaking. Okay. All right. So the first thing that we're going to do is notice that I don't have a left or a right. Okay. So what I'm going to do is I'm going to say int left equals 0. Okay. And then I'm going to say int right is equal to what?
Array dot length -1.
Good. You seem like you're really getting this. Do you get it, Eon?
Yeah.
Very good. Okay, because that's very good. Okay. All right. So then what we're going to do is we're basically going to shift this over. What we're going to do is we're going to change this to a while loop, and we're going to say while. Okay. While left is less than or equal to right. Okay. And we're going to get this. Get rid of this. Now, there is a possibility of an error with this line right here. There is a possibility. I don't see them asking you, but who can tell me what that possibility might be? Euban? Dylan?
Possibly if the array length is 0.
Well, what if we have data overflow? What happens when you add too many arrays? Or the length of too many arrays? What if we go to the array index max or whatever?
Would that occur?
It's a possibility. Okay. It is a possibility. And that's usually if we're dealing with 2 arrays. Okay. It's usually a 2 array thing. Okay. But right now that's a possibility. We don't need to worry about that right now. Okay. So the next thing we're going to say is this. We're going to say if array mid equals true, or equals key, return true. Okay. Else, now here's the thing that we're going to switch though. Okay. Otherwise, what we're going to do is this. Oops. Otherwise, what we're going to do is this. Okay. Rather than recursion, why isn't this going commenting? I'll just get rid of it. Okay. Else, if the key is less than array.mid, what we're going to say is right equals mid -1. And then otherwise, left is equal to mid +1. Okay. So this is the iterative way to do it. Okay. Now, either one works. Okay. Now, which one do you think is faster? They both should be about the same speed. Okay. But as you can see, the recursive way is just cleaner. It's just sicker. It's just a much cooler way to do it. Okay. So that is what we are learning today. As you can see, like, took up a good amount of time just to go over binary search. Okay. All right. So let's take a look real quick at your homework. Give me 1 second, guys. Where is it? I just had it. Is this it? Bingo, bingo. Cancel. I want to print it. All right. So let's take a look real quick at your homework. Okay. Now, again, if you guys have printers, it'll save my eyes. I would really appreciate it. But if you don't, I completely understand. So take a look at this worksheet. Okay. So the target is 21. So binary. So what you're doing, it is a sorted array. And each pass, you're going to have a low, a mid, and a high. Okay. What you're going through is you're just going to go through and choose which one was the low on the first pass, which was the low, which was the mid, and which was the high. So for example, let's say the target 21. Okay. What would the low be?
-5.
-5. And what would the high be?
43.
And then the mid would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we know that it's 9 divided by 2 would be 4, 0, 1, 2, 3, 4. So the mid would be 7. Okay. Now, we know it's greater. So what would our next low be?
10,
And what would our next high be?
43,
And our mid would be,
12.
12. Yeah.
what's 4 divided by 2?
Oh, it's 21. My bad.
21.
The mid would be 21. So how many passes would we have to make?
2.
2.
Just 2. Because does the key equal mid? Yes, it does.
Yeah.
We have 2 passes. Okay. Pretty brilliant, right? I hate my life. All right. So, okay. Nobody's supposed to agree with that. All right. So that being said, that is what I want you guys to do. And this worksheet is killer. Very good for doing this. Okay. And as you can see, it goes a little bit progressively, not harder and stuff like that. So, all right. So anybody have any questions? Now, as you guys can see, linear search is a lot easier. Okay, let me stop sharing. A linear search is a lot easier, guys, because with a linear search, you don't really have to do much. Like you can just use a simple for loop and go through. It doesn't need to be sorted, but you have to have an understanding of the principles of how different searches work, just like with different sorts. So this is more of a divide and conquer approach to searching. Okay. Now, is there a binary search method? Yes, there is. Okay. But you have no idea how it works. Now you do. Okay. Does anybody have any questions? How many of you felt I explained it pretty well? Okay. All right. Perfect. So this is your homework. It's due tonight before 11:59. Okay. Do I have you guys tomorrow? Okay, I have you guys tomorrow. So tomorrow we will just review searches and sorts all over again so that you guys kind of have them, but also get ready for your free response exam on Monday. You will also have a quiz tomorrow. Okay, so first things quiz, we'll review the worksheet, go from there. Understood? All right, great job. Now, again, if you can print it out, please write in clear numbers. Okay, please write in clear numbers for my vision safety. Okay. And take a picture, a clear picture of it and upload the picture. Understood? All right, great class today, guys. Good job. I'll see you guys later.
Thank you.